Write and balance the equation for the combustion of C6H14. When we have a combustion reaction, what that means is that we're adding oxygen, and for our hydrocarbons, our only products are going to be CO2 and water. So I'm going to start by writing the basics of our reaction. So we have C6H14 plus O2 yields CO2 plus water. And because this is going to start out balanced, I'm leaving some room for my coefficients as I go through and balance this equation. Now I'm going to create a list of my elements so that I can basically create a tally, C, H, and O, of how many carbons, hydrogens, and oxygens I have on both sides of the equation. So on the left side, I see I have 6 carbons, 14 hydrogens, and 2 oxygens. On the right side, I have 1 carbon, 2 hydrogens, and 3 oxygens. So now what I need to do is start putting in coefficients and adjusting my totals until I get all the coefficients I need to have a balanced chemical equation. So I'm going to start by putting a 6 in front of the CO2 so that I can balance the carbon. So that changes from 1 carbon to 6 carbons on the right, but notice that it also changes the number of oxygens. Now I have 12 plus 1, or 13 oxygens on the right side of the equation. So now my carbons are balanced. Now I'm going to look at the hydrogens, and in order to balance the hydrogens, I need a 7 on the right side of the equation. So now I have 14 hydrogens, and that also changes the number of oxygens. So now I have 12 oxygens plus 7, or 19 oxygens. Now at this point, both my carbons and my hydrogens are balanced. It's only the oxygens that are not balanced. And when I look at the left side, what I notice is that I have oxygen all by itself. So what I'm going to do is, for a moment, I'm going to pretend that the 2 is not there, and I'm going to say, what coefficient would I need in front of that oxygen in order to get a balanced equation? And I'm going to say, well, if I put a 19 in there, then I would have a balanced equation. But that's assuming that the 2 is not there. But I can see that I would have the right number of everything. But I do have the 2 in there, so what I have to do is actually change that coefficient to 19 halves and return that 2 into the equation. So now I actually do have a balanced equation, but I still have this fractional number in my coefficients, which I don't want to leave in there. So what I can do is I can multiply everything through by 2, and when I do that, I get a 2 here. I get a 19 in front of the oxygen. I get 12 in front of CO2, and I get 14 in front of H2O. Now I can go back and check my count. I see that I have 12 carbons on the left, I have 28 hydrogens, and I have 38 oxygens. On the right side of my equation, I have 12 carbons, I have 24 oxygens in the CO2 plus additional 14 oxygens in the water for a total of 38 oxygens, and I have 28 hydrogens. Now I have a balanced chemical equation with integers as coefficients, and I see that that's the lowest possible set of integers because I cannot divide it by any number and still get whole numbers. So it looks a little odd to have values that are this large, but we do see this when we start looking at larger reactants, particularly when we look at combustion reactions.